अब्दुल मालिक समझ में आयो RNN?
सर आयो आहे इहो कंप्यूटेशन बि समझ अचे थी जी प्रैक्टिस कंदुमि मां हाणे जीअं क्लास ख़तम थिए उन खां पोइ
शादिब
हिकिड़ी ॿी क्लास आहे राति प्रैक्टिस कंदुमि बाक़ी
शादिब
जी जी सर
केतिरो % समझ में आयो शादिब?
हाँ सर अची वियो आहे तक़रीबन 60 to 70%, बाक़ी वरी कुझु प्रैक्टिस वग़ैरह कंदा त अची वेंदो।
Okay, very good, yeah, excellent, zabardast. Okay, let's move forward. I don't know where other guys are gone. Maybe they are offering prayer. Mana ॿ खां 3 मिंट ॾिसूं था कुझु ॿिया अची वञनि. In the meantime, I can upload the recording of first half. Okay. Come on. LMS. My course is data science. Okay. Okay. Edit RNN and LSTM. Okay.
अगरि टी ब्रेक बि करे वरितो, असांजो नाश्तो बि न कयो आहे।
Lecture RNN and LSTM part 1. तव्हां नाश्तो न कयो, तव्हांखे शर्म नथो अचे हिन टाइम ते नाश्तो न कयो अथव? मां को हया को शर्म अथव?
सर एक्चुअली 12 बजे उथिया ते तव्हांजी क्लास हुई त 12:30 खां उहा नॉर्मली क्लास स्टार्ट थींदा आहिनि, उहो नाश्तो न करिणो पियो।
माना छो नथा उथो 5 वॻे या 6 वॻे या 7 वॻे?
5 त सुम्हंदा, उथूं कीअं?
यार
सर मुंहिंजी रूटीन हिते अची चेंज थी वई आहे।
कीअं हाणे जल्दी सुम्ही? माना यार
सुबुह जो 6 बजे उथाइनि था सर।
गुड यार, सुठी बाबा। अलाए इहो 5 AM क्लब पढ़ियो अथव अलाए कोन पढ़ियो अथव? शादी पढ़ियो थी 5 AM क्लब?
नो सर।
इहो पढ़ो न यार, इहो इन रॉबिन शर्मा जो अथव 5 AM क्लब. You पढ़ो, you must read that. I mean, you will come to know what are the wonders of waking up early. Honestly speaking, माना आऊं usually 10 साढ़े 10 11 बजे ताईं माना एतिरी त प्रोडक्टिविटी थी वेंदी आहे जो अर्ली ऑफिस अचण जे करे ऐं अर्ली कुझु स्टडी करण जे करे जो माण्हू पूरो रिलैक्स हूंदो, माण्हू ख़बर अथव वॉट एवर प्रोडक्टिविटी आई हैड टू डू फॉर द डे मोर और लेस आई हैव डन. छा मतिलबु माइंड ॾाढो फ्रेश हूंदो आहे. अगरि माण्हू लेट कमु शुरू करे थो 11 साढ़े 12 खां पोइ अगरि तव्हां शुरू करे पंहिंजो ॾींहुं सॼो ॾींहुं तव्हां न बेचैन हूंदो त यू ऑलरेडी लॉस्ट अ गुड पार्ट ऑफ द डे. एंड बायोलॉजिकल क्लॉक, नेचुरल क्लॉक, बॉडी क्लॉक, ये सब डिस्कशन हम पास में करे चुके हैं ना. Okay, so let's resume. We have seen how backpropagation takes place. I mean, recurrent neural network programmatically. I mean, initially, Noor, are you there? You can see initially state t equal to 0. So output is equal to function of input and state, and the current state equal to this output. And this loop continues till we have seen all the sequences in the input. And this function is actually some activation and input, actually dot between weight matrix and input, and then state t is actually dot matrix between another matrix and previous state, and plus bias. So programmatically, I mean, if you do not understand mathematics, you can understand it programmatically. I think this is for the guys like Malik, those who say that we understand things more when we see them in programming language, when we see them in coding form. So same mathematical equation is actually it's equivalent here in programming, right? This also gives you better idea of the recurrent neural network. We have input, right? And when we see input, uh, the input to the network is actually being sent, uh, not only the input but also the previous state. And when we are at time stamp 1, the previous state is 0, right? So this input and previous state, it calculates output, and this output is sent as the input to the next stage, right? So in next stage, we have got this input and output from previous stage, and we produce output. And the good thing is that each step, at each at, at each step, the RNN is also producing output. It's up to you. You want to grab that output or you want to ignore it, right? So in previous case, you can see I initially said I want to predict a word, the character after HELL. But when I then also saw what network is predicting after H and E, we saw that the prediction was wrong. So backpropagation starts, right? And at each step, the output is actually activation between input and W and previous state and U, right? And plus bias. Okay, now let's see how it works uh, in Keras. Very simple. I mean, just 5 minutes. You know, you import simple RNN, right? You again create a sequential network, but this time rather than adding a fully connected dense neural network, we will be adding a simple RNN. And it will have output 32. And what is its input? Its input is coming from embedding layer. And that embedding layer, we have already seen in previous class how embedding layer is aided in a sequential model. We say we will be considering 10,000 unique words, and each of the words will be encoded as a 32-bit, right? Then you can see summary of this model, right? If you want to add more, layer, then output from this layer should be turned to true, because otherwise, when you turn it false, then more layer cannot be added, right? We'll see when we are, here is the next example. It's not necessary that you have got only one layer and hidden layer. You can also have multiple layer. You can see here, first layer, its output is being sent to second layer, its output being sent to third layer, and its output being sent to fourth layer. And fourth layer, it's not set to true. And then we just see the summary of the model. It is here, right? So we create sequential model. We add embedding layer. You have already seen in previous example how embedding layer is headed and what is embedding layer. We've already seen in the previous example. And then we've got 4 layer of simple RNN, right? So let us see complete example. Let's see complete example. Here we are saying we are going to load IMDb, right? You know that train, it's a Y, taste, it's a Y, right? So we load data, we see its length, right? 25,000 in training, 25,000 in test, right? We paired sequences. You know why we are doing it? We paired sequences. We say input train, this one, and maximum length equal to 500. So we are considering a review up to 500 word, right? So we paired sequences by 500. You know, those which are smaller than 500, they will be padded, and those which are bigger than 500 words, they will be truncated. So we do it for the training as well as for test, and then we see its shape, which is actually, now you can see total 25,000 instances, and each of them is 500 dimension long. Same for training as well as for test, right? I don't know what's wrong with Iman. I mean, he's joining. Admit all. Okay. So then once the data is prepared, we import this model. We create sequential model, embedding layer, right? Maximum feature, which is 10,000. So 10,000 by 32. Then 10,000 by 32. We add just one layer, right? And the output is 1 for the fully connected. You know why? Because it's a binary problem. A review can either be positive or negative, right? It's sentiment analysis. We are using sigmoid because it is binary, right? Then we compile the model the way we have been compiling our fully connected dense neural network. Then we fit on the model. We provide input training data, corresponding labels, right, for 10 epochs, and we say from this training data, 20% of the data should be used for the validation purpose, right? Uh, when I run this, you can see we achieve an accuracy around 83%. Yes, model overfits after probably fourth epoch. You can see here 84, and then validation accuracy starts stalling, which means that model is overfitting, right? So you can see here after fourth epoch, this is the maximum that we can get around fourth epoch. After that, model actually starts overfitting, right? Now, by the way, the accuracy, the max accuracy that we can achieve here is around 84%. And if you can recall, as a reminder, in chapter 3, our very first naive approach to this data set got us 88% accuracy. Huh? I mean, when we were using sequential fully connected, we saw 88% accuracy on IMDb. But here, we are getting accuracy of 84%. Then you might argue that, come on, we learned RNN. You said that RNN actually works better on sequences. It works better on text, but fully connected, the simple naive approach gave us 88% validation accuracy, and this one is giving us around 83-84% accuracy before being overfitted. The answer is simple. I mean, there are two things. The one is we were considering all unique words, here only 10,000, and the maximum review length here we consider 500, whereas in fully connected we were giving it all the data available, right? And the unique words that we have in this data set are around 88,000. So if you increase the feature size and if you increase the length of each review, you will see that RNN will beat 88% accuracy that we got on sequential. You can reach up to 93-94%. Right, got the idea? Any question up to this point?
सर क्वेश्चन नहीं है।
नो सर, नो क्वेश्चन।
ओके
सर ये शकील को ऐड कर दें, वो बोल रहा है मैं ऐड नहीं हूँ।
शकील ज्वाइन करेगा तो ऐड हो जाएगा ना। ओके, राइट। Okay, so we have seen simple RNN and Keras, very simple, right? You can see using embedding layer to learn word embedding, we achieve 76% accuracy. They are accurate 83%, and you know all these things. We are well clear. Using pre-trained embedding, can you do this? I mean, when you do this, you will achieve 56% accuracy. Do this experiment. I'm not saying do it now, but I'm saying when class is finished, you can do.
सर ये वही नहीं है जो हमने पहले किया हुआ है, वहाँ पे यही 56% एक्यूरेसी थी।
ठीक है।
I think आप नहीं करवाया हुआ है सर।
हाँ, using embedding layer with pre-trained on similar. या थोड़ा वेट करें, बड़ी नमाज हो जाए, या अज़ान हो जाए। Okay, so the accuracy in first chapter we got 88%, but here we got 85%. The reason 500 words and you know uh, 10,000 features, right? So here, what I'm saying, repeat this RNN with 10,000, with 1,000 review size and 25,000 features. Let's do it. Let's do it. I mean, it won't take a lot of time, so we should do it. So I import RNN, Kiras, right? Uh, I don't need to compile this one. I don't need to compile this one. I compile importing. Let it be imported. So you can see when you print summary, it shows you the full model. You set this true usually when you want to add next layer, as we have done it in this case, right? It should not take a lot of time. Why? Okay, right. So you can see this has been executed, right? And when you set this true, you can add more layer, and then you can display summary of this model, right? I'm going to load IMDb, and I need to update it. Rather than 10,000 feature, I make 25,000 feature, 25,000 feature, right? And 1,000 review size, right? Let's see then what happens. When we provide more information to the model, right? Simple one layer and RNN, and let's see if performance improves. I mean, in previous case, you saw it reached only around 83, 84%. Let's see if it can improve from 83, 84%. Right. So we're training on 20,000 sample and validation on 5,000 sample. So let it be running. We can move ahead. Right. So rerun review 10,000. Okay, we are doing it. Simple RNN is not processing for long sequences. LSTM is the next big thing. I mean, even with this structure, we say the vanishing gradient is a problem in a simple RNN. When I say vanishing gradient, I mean that because it is chain rule, so probably when you go in remote past, you will slowly, gradually be forgetting, what you saw previously. Just imagine if I've got a very big sentence, for example, a sentence which is like uh, when I when I saw when I saw when I saw when I saw money heist, money heist, money heist, I was overwhelmed. This this series this series is actually the best I have ever seen. Now see here, when I reach here, this series, now this series is dependent on something which is in remote past. Overwhelmed is not being referred by this series. Was is not being referred by this series. I is not being referred by this series. Money heist is being referred by this series. I mean, say for example, I write a lot here, and then I again say the series, the season, which I saw is wow. Huh? If I write something like this, you know that this season is also referring to money heist. So we can say that these are the long-term dependencies, or you can say the co-referencing. Now, when you are doing it with RNN, you can see probably when this guy, the one here, is dependent on maybe here, then a very minute representation of remote past will be available in the previous state. So they say that, and you need to change it. They say that when you are cascading information from one step to other, then maybe when it is the distance is too big, then you might have already forgotten what you are actually referring to. Because here, when you are saying the season, it might have, the previous word is this one, so this word might not have sufficient information to encode money heist. So there, RNN is bound to make some mistake. So that is the reason why they say just do a small change in the model, and that change is actually this one. So they say leave everything else as is. The only change is now you give previous input, but also full document, but also complete document. You can see here, here is another input, here is another input, and that input, you can call it carry or you can call it anything, but it is actually an extra input to each state. Not only the previous state, not only the previous state, but also this carry. Now, what is this carry? This carry mathematically is actually this thing. We say the output equal to, you perform activation on previous state and u0 plus dot input and current 0 and plus ct. uh, in this case, you can see output at each stage is actually function of three quantities rather than two quantities, three quantities. This is the first quantity, second quantity, and third quantity. You can say the first quantity is coming from here, second quantity is previous state, and third quantity is actually this C. Now, what is this C? The C is actually IT into KT and plus CT into FT. So at each state, CT plus 1 is equal to IT into KT plus CT, the previous CT into FT. Now, what are the IT, FT, and KT? These are three more quantities. So, first quantity is IT, which is activation between previous state, and UI, the current matrix, plus current input and WI plus BI. The FT is equal to actually dot matrix between previous state and UF, another matrix, input T into WF plus BF. Similarly, the KT is equal to previous state into UK plus input, current input and WK and plus BK. And then when you do this calculation, you will actually be updating, this information at each state. So it is actually, I mean, mathematically, if you see, you are doing nothing. You are actually amplifying the previous state. So here at each state, this previous state is being updated. It's not that now this previous state is only dependent on the previous output. No, now this previous state is actually being continuously updated. So you can say this is actually concatenating whole information. So when you reach actually Cn, that Cn will be kind of concatenation. You can see actually it is concatenation. So it is concatenation of all what it has seen in the past. Which means that now when I reach here, I do not have access to only previous input, but also previous all inputs. So in a way, you can see whole history is being now given at each step. And mathematically, how we are capturing it? We are capturing it by just, this concatenation between, KT, IT, and FT. Right. So CT plus 1 at this stage, this is actually equal to, IT, KT, and this previous CT. So when I say previous CT, which means that it is being concatenated. So you can see now at each step, this additional information that we are passing to our RNN is actually giving, remote past context, which it might require in order to do the better predictions. Right. You can see here anatomy of an LSTM. Again, this can even be computed in multiple different ways, not only just one way, but it can be, a different connection. And so if you want the input information, you can do that. So you can see even this extra connection, it gives more information to the CT to better understand the context. The whole idea is we just want some, weight metrics which can give us information about not only the previous input, but also the whole history, what we have seen so far. Right, got the idea? Got the idea?
जी सर जी.
Iman? Iman, is it clear? Sham?
Yes, sir.
Okay, okay. And then by the way, why this name is in Chinese? Hamza, huh? Okay, Ali Hamza. I don't know which font he has selected. Okay, usually,
Hafiz Ali Hamza.
Hana, we usually write these type of fonts when we send marriage invitation. Ali Hamza getting married.
Maybe sir, he's obsessed with that.
Huh?
Maybe he's obsessed with marriages.
Maybe. Okay. Neha, are you clear? Neha, are you clear?
Yes, sir.
Okay. Thank you, beta.
Yes, sir.
Okay.
Yes, sir.
Okay.
Yes, sir. Yes, sir.
Okay. Now, let us see the implementation of this. I mean, come on. This is Kiras. Just a couple of lines of code change and RN becomes LSTM. By the way, let us see our performance. You can see performance has improved 85. It reaches 85. Previously, only after 2 iterations, it reaches 85. Previously, it reached only 84, but now performance is improving. It is improving
वो भी
because
85 था आपने जो लिखा था.
Yeah, we have improved this from unique words, maximum features 25,000, and the review length is 1,000. So certainly performance will improve. Right. Okay. Let's see LSTM. As I told you earlier, this is Kiras. Kiras actually hides a lot of details. So you can see here sequential model, embedding layer. We add LSTM. Then we have got this dense layer, output layer, compile, and that's it. Right. We have already loaded the data set. This time we are considering 25,000 unique features, and the review length is 1,000 words. Right. So we do it on LSTM. And you will see that LSTM will be performing better than RNN, because LSTM have got access to a lot more data than RNN. RNN has access only to previous state, which very minutely represents remote past. But when you are talking about LSTM, it has got extra information, and that extra information is actually the CT, which is being computed at each step and being concatenated with whatever it has seen in past. Right. So that is the reason why LSTM is richer in terms of inputs when you want to calculate at each step the output. Right. So let it perform this task, but we should be able to achieve a very good accuracy on that. Let's see. I think I have written here class assignment. By the way, I can guarantee it will improve RNN, but here is the class assignment. I want you to perform this. Use pre-trained GLOVE and LSTM, see the effect on accuracy. So far with LSTM and RNN, we have been using embedding layer, which means
GLOVE वही 100 dimension वाला use करना है.
Yes, 100 dimension with the GLOVE, and then see what happens. Here we are using only 32 dimension. So obviously, if you are using glove with 100 dimension or maybe 200 dimension or 300 dimension, whatever you use,
Okay, sir.
accordingly you will update the LSTM layer. But what I want that you need to make a sense that whether when you use pre-trained glove with LSTM, does performance improve or not. I'm not asking you to do it now. When we finish class, you can do this assignment. But pre-trained glove with the LSTM and RNN should give you more understanding of processing and text. Right. Okay, so I also want you guys apply LSTM and router data set. I mean, if you go back 78 page number in our book, you will see that how fully connected perform. I want just one question: does LSTM perform better than the fully connected? If you just recall the experiment we did in first chapter when we performed, on routers classifying movie reviews and see how much accuracy. I think it was around 78%, 78 or 79%. So LSTM should be performing better. You can do multiple experiments. I mean, one experiment with LSTM learning embedding from router, and second maybe LSTM loading glove. Multiple experiments you can perform just to see which combination performs best. Right. I mean, usually when you have a dropout issue in RNN, you can use recurring dropout. You can stack multiple recurring layer, or you can also learn bidirectional, LSTM or bidirectional RNN. The bidirectional concept is also wonderful. I mean, they say that if you can understand statistical structure of sequence by watching from left to right, then if you also see it from right to left, then your understanding about the sequence will be much richer. So when you use bidirectional LSTM or bidirectional GRU, they usually process sequence. They usually train not only by looking at the sequence from left to right, but also from right to left. So bidirectional LSTMs are very effective in improving performance. When you are using just one directional, you mean that, I mean, see here, the idea is, if I tell you I eat apple, now if I say I eat, what should be next word after eat? You will say apple. But when I say apple eat I, now I'm asking you what should be the next word after apple eat? You will say I. It means that you will be making more sense. You have seen that eat and apple twice. So you saw once apple comes after eat, and then you saw that eat comes after apple. So you actually make more connection between these two, words. So a statistical pattern that you're going to establish because watching the sequence twice, one from left to right and then from right to left. It means that the weights that you're updating, they will actually establish better friendship between these words, which are occurring together. They did not see them only once when you were traveling from left to right, but they also saw them when they were traveling from right to left. Right. So the idea in bidirectional LSTM is you do nothing, you have got training data, and when you reverse the sequence, you are kind of doubling your training data. You are kind of increasing size of your training data. So you are saying that I eat apple, apple eat I. So now there are two, instances of the same instance. And the good thing is, because you are giving the inverse sequence, which means that eat an apple, your network might have seen once, now it sees twice. It means that the connection that it has to establish between these two words will be further strengthened. So that is the reason why they say when you do this bidirectional LSTM, it usually performs better than single LSTM. My God, you can see here, you can see here, it's already 87%. It's already 87%. We saw that RNN, the max it reached, it was around 85%. But when we do it with LSTM, it is already reaching 87%. right? Uh, then after this by LSTM, you can see by LSTM example, I will show you. But then there's another very important aspect. I mean, they say, I mean, for many decades, we thought that CNN is for images and LSTM is for text. But recently, I mean, only recently, in 2017, 2018, people started using CNN for processing text. They say when you are processing image, your filter size is 3 by 3. Your filter size is 3 by 3 or maybe 5 by 5 because because if this is an image, you need a two-dimensional filter size because you need part of the image. So maybe this part of the image, then this part of the image, then this part of the image, and so on. So the filter size is 2D when you are processing images. They said, oh, how about if this is sentence, how about a CNN with filter size of 1D, which is, if this is complete sentence, say for example, you say you can process, maybe filter size is 2, or maybe 3. It means that you are processing these 3 characters first time, then these 3 characters, then these 3 characters, and so on. So they said, okay, RNN wanted to see the history. How about CNN, which can process multiple words at a time? So, I mean, ultimate problem is you want to see what occurred before P. How about if I give you whole apple? If you see whole apple, you can make more sense what appears before P, what appears after P, what appears after L, what appears before L. So they say that when you have got the CNN and filter size one dimensional, you can play with any sequence size, and even CNN can be used to process text, right? So you can see here, if I say this is my input sequence, then window of size 5, you are processing it. By processing it, you will update some weight matrix, then increase this window to next location, and so on. And the advantage is, yes, their accuracy is not as good as LSTM. I mean, their accuracy is still, because here when you move it forward, you actually forgot everything about what we saw here, because it is not really maintaining the whole history, huh? Just one window at a time. So when you process this window and when you shifted here, you actually forgot everything about this window. That is the disadvantage in CNN. That is the reason why long dependencies, CNN is not very efficient to deal with, right? But the good thing is the inherent, faster processing of CNN is quite advantageous. I mean, in this case, your CNN is extremely fast. I mean, it can very quickly do all this computation, even for your even on your CPUs. So maybe 1/10 of the time. So if your if your CPU is taking 10 minutes to process LSTM, probably your CNN will take only 1 minute. So the biggest attraction of processing text with CNN is, it's faster processing. Right. Let's see one example how we can process, text with CNN. So we saw this example, huh? I mean, the accuracy 87%, 89%. I think their model is started overfitting. So you can see the accuracy there we achieved around 85%, but with LSTM we achieved around 89%. Right. Now let us see a processing sequence with the convolutional neural network. Right. So again, 10,000 words, 500 is the review side. We prepare data. Right. We see the dimension, and here now I'm creating a sequential neural network. I add embedding. You know why? We need to convert, word into vector. So we have this embedding layer, 10,000 by 128. and the input is 500 words at a time, right? The first layer, the first convolution layer, you can see it is one dimension. It is one dimension. It is not 2D. When we were doing it with images, it was 2D, because images by their nature, they are matrices. But here, words are sequences, they are vector. So because they are vector, so we actually play with one dimension, right? So we say that the output of this layer will be 32, right? And the filter size is 7. It means we are processing 7 words at a time, right? So the filter size is 7 here, and the activation we are performing is ReLU. Then we do max pooling, right? Then another layer of 1D, again the filter size is 7, output is 32, and then we do global max pooling. I mean, global max pooling is just like when you're flattening. You know, you can do flattening or you can do global max pooling 1D. So we say that convert this whole uh, matrix form into vector, and then we are passing it to a fully connected dense layer whose output is only 1, because it can either be a positive review or a negative review. So we have created.
तो यहाँ वन सर यहाँ पे 1D क्या शो कर रहा है? Global max pooling 1D.
See, 1D, if you can recall, when we were doing images with CNN, it was 2D. It was 2 dimension.
Yes, sir.
It was 2 dimension. Image is 2 dimension, because image is a matrix. All these intensities are actually in matrix form. But when you're talking about a sequence, a text sequence, it is actually 1 dimensional, right? It is just vector. So that is the reason why we need a convolutional neural network of 1 dimension. But when you are playing CNN with the images, you will have convolutional neural network with 2 dimensions. And when you are processing video, you probably will have convolutional neural network with 5 dimensions.
Five dimension.
I'm still not entering into that discussion, but when you're processing video, it is convolutional neural network with 5 dimension, right? Here, because we are processing sequence, and sequence by nature are vector, that is the reason why we are giving it 1 dimension. Right. Then we see summary of the network, we compile it, and we fit it. Believe me, it is extremely fast progress. You can see in previous example, it took ages, but this one, I'm importing Keras, and then I will, load the data set. You will see the process. I mean, the processing will be extremely quick. Its performance will not be better than LSTM, but sometimes if we do not have access to GPU, if our data set is too huge, then we might use CNN just to get good enough accuracy. We may not be getting an accuracy same as LSTM, but its accuracy will be comparable to LSTM. We compile it, then I also run this, so you can see the processing. Processing will be very fast. Processing will be very fast. You can see here. This one is still running. ये अभी भी चल रहा है. ये अभी हमारा जो LSTM है, ये अभी भी चल रहा है. ये मेरे ख्याल में इससे पहले ही फिनिश कर लेगा. ये इससे पहले ही फिनिश कर लेगा. Yes, its accuracy will not be reaching here, but I'm sure that ये उससे पहले खत्म कर लेगा ना. So when you're processing with sequences with CNN, this is how you can do it. Just 1 dimensional filter, and everything else is same as you have been doing for image processing. So CNN can be used for sequence processing, and people came up with this beautiful idea just to increase progress of the processing, right? And usually they combine RNN with CNN. Usually they combine RNN with CNN just to process long sequences. I will show you a couple of examples maybe in next class. Let's see the performance LSTM and CNN, comparing them. Combining CNN and RNN. I mean, this is actually doing on regression, so I do not want to cover this example, because I am not covering regression in this course. Just wrapping it up, In the same way that 2D convolutions perform well for processing visual pattern in 2D space, 1D convolutions perform well for processing temporal patterns. They offer a faster alternative to RNN on some problem, particularly on NLP tasks. Right. The second is typically 1D convolutions are structured much like 2D equivalent from the world of computer vision. They consist of stacks of convo 1D layer and max pooling 1D layer, eventually ending up a global pooling operation, or you can say flattening, right? And you need to do it because you need to again convert vector and matrix in a vector. Because RNN are extremely expensive for processing very long sequences, but 1D components are cheap. They are very fast. It can be a good idea to use a 1D component as a pre-processing step to RNN. Wow, wow. I mean, they say break long sequences into short sequences and then let the RNN do remaining job. Shortening the sequences and extracting useful pattern for RNN to process, because usually RNN forgets about past, so we say that let's break sequences through CNN and then let the RNN do the rest of the job. So one useful and important concept that we will not cover in these pages is that 1D convolution with dilated kernels. Just ignore this sentence. Right. So in these couple of hours, we have covered the RNN concept, the mathematics behind RNN, and then some modification in RNN to create CNN, and then we understand by LSTM. I can show you. I think I should have one example of by LSTM. We should have here. By LSTM is again, Kiras has made it very simple for you. It just adds one layer of by LSTM rather than LSTM. This is a regression example. I mean, if you are playing with some regression problem, I recommend that you cover this thing also. But because I have hardly worked on regression, so I have skipped this. I think by LSTM, first baseline, okay, use of dropout. By the way, this is how you can add dropout in LSTM or in RNN. You add this GRU, right? With GRU or LSTM or with RNN, the second parameter is dropout. The third parameter is recurrent dropout. So you can use these to fight with overfitting. Right, it will be a good experiment if you do these with our previous LSTM and RNN course. Just add dropout and add recurrent dropout and see what happens. Right, and because this is regression, so you can see our loss function is MAE. Right. Okay, and that is checking up a recurrent neural network. You can see GRU, another layer, and then dense layer. This is for regression. Now here is the bidirectional LSTM. Bidirectional LSTM. You do nothing. You have GRU, okay, and then okay, maybe here. Yes, this one. So you can see here we import IMDb again, 10,000 feature, 500 for one review. Load the data, right? Do the padding, and then embedding layer. That's okay. But where is by LSTM? Yes, by LSTM. Then this should be. So you can see we are doing same thing, embedding layer, right? And then bidirectional, nothing else. Previously, the only change is if you want to use by LSTM, I mean, you want that network should not only learn from left to right, but it should also run from right to left, right? So you are kind of improving the understanding of network about your data, right? So when you are doing LSTM, you do this, and when you are doing by LSTM, this is just add layer.lstm, and when by LSTM, you say add layer.bidirectional, and then you pass same LSTM here, right? That's all. I mean, Kiras has made our life very simple. So usually when you see that performance is not improving, you can use bidirectional LSTM, and you should also be using a dropout with by LSTM. Then performance can further be improved. Right. So LSTM gave us accuracy around 89%. If you use by LSTM with the dropout and recurring dropout, you can reach around, I think, 90 to 91%. I'm expecting that you will perform the experiments. Right. This one is the example of regression. You can ignore it. Right. Going even further, adjust the number of units, uh, try LSTM instead of GRU, try bigger densely connected regressor. I mean, you can do a lot of experiments, and I always recommend that all the experiments that book is suggesting you should do, only then you will have more grip on all these concepts. Right. So you can see this one is our LSTM and this one is our CNN. CNN has already ended. CNN, we ran for 20 epochs. It has already ended. It has already ended. LSTM, which we started even before this, it is still running. So you can see CNN is really fast. CNN is really very fast. Right. Its accuracy may not be as good as I think it was this one or that one, 40 or 40. Yeah, sequential bidirectional. Okay, yeah, this one. I think this one. Right. So you can see these 20 epochs ended uh, well before 10 epochs of LSTM. Yes, accuracy, it might be better than CNN, but the processing of CNN is much faster than LSTM. Here, the accuracy should be around 80-81%. Here we have used only loss. Either this one or it is still. Oh, sorry. Your CNN is here. Your CNN is here. I was wondering why we are not reporting accuracy. So accuracy is being reported here. It is now in 60 poke. So it is in 60 poke and this one is in 90 poke. But my expectation is this guy should finish before this guy, because usually RNN or LSTM is much slower than their corresponding CNN. Right, so let them finish the processing. I end my lecture here. If you have any question, you can ask. Otherwise, I want to discuss assignment with you. I'm not sure how many of you have seen the assignment. Please see this assignment. This is around 5 to 10 hours assignment, so you should spend some time. The submission deadline is next Wednesday. What you need to do, there are actually around, I think, 11 tasks, 11 experiments. So what you will be
वेडनेसडे
doing,
के बजाय थर्सडे कर दे आप,
uh,
क्योंकि क्यूरीज होंगी तो हम उस दिन पूछ लेंगे और रात को सबमिट कर देंगे.
चले. This task is about document classification. सेंटिमेंट एनालिसिस मैंने आपको करा लिया है क्लास के अंदर. अब हम करें डॉक्यूमेंट क्लासिफिकेशन. बीबीसी का डेटा सेट, इसके ऊपर हमने पहले काम किया है मालिक. बीबीसी का जो इंग्लिश डेटा सेट है. नहीं सर, उर्दू पे किया है.
नहीं सर, वो हमने उर्दू पे किया था. वो भी हमने सर एक्सट्रैक्शन सीखी थी.
हाँ ठीक है.
वेब स्क्रैपिंग सर.
यस सर, स्क्रैपिंग सीखी.
दैट्स ओके. अब ये इफ यू सी डेटा साइंस, डेटा सेट्स, router, if you see BBC data set, fall 2019 deep learning data sets, BBC. It's actually this data set. It has all these news stories in business, entertainment, politics, sports, and tech, and almost each folder is having more than 400 files, more than 400, or maybe more than 300 basically. In sports there are 11. In politics, there are 417 files, and in entertainment, there are 386 files, and in business, there are 510 files. So minimum 386. So what I want you to do, I want you to read all the news stories under these 5 labels. Read each file, keep that text in this array and their corresponding label here, right? Read all these stories and keep the text here and their label here. So when you are reading these files from business category, so read first file and read all this text, and you will have to keep it at 0th location of text array, right? And read all these 500. For all these, the corresponding label should be business, right? When you complete reading all business, you come back, read all entertainment. Read one file at a time, keep that text in text, and the label, corresponding label should be entertainment, and that should come into labels, right? So when you have completed reading process, all the text file should be here and their corresponding labels should be here, right? When this is done, you do tokenization. Use maximum news word size 200 and use maximum 20,000 unique features to classify the text. Now perform following experiments and report the accuracy. In each of these cases, use 300 files to train the model and remaining to test the model. The first experiment is simple, fully connected two hidden layer, dense layer model. Choose output hidden layer as per the model configuration and your choice. Up to you. Learn the word embedding, 20,000 by 32. You know the dimension. Then simple, fully connected. This time load glove. So this is embedding layer. This is glove. Network is same, right? Then use fast text. We have not covered fast text in class, but I want you to explore and see how fast text is loaded inside sequential network. So you load fast text and use same network, right? So these are the three experiments. The first experiment, network is same, embedding layer, glove, fast text, right? Report all these, the accuracies inside your Python notebook. Then use RNN with embedding layer, with glove, and then repeat the experiment with RNN stack. Here only one RNN, here stacked RNN, embedding layer and glove. Then change RNN to LSTM and repeat this 4 to 6. These are 11 experiments, and I want you to develop a table. In each table, just report accuracy, like accuracy of experiment 1, accuracy of experiment 2, accuracy of experiment 3, up to experiment 11. Believe me, this assignment is extremely, kind of addicting assignment. If you just engage with that, you will forget if you have eaten your lunch or not. You should even forget uh, everything around the world. Such is the level of interestingness in this assignment, and I'm expecting that you will be spending around maybe 15 to 20 hours just to complete this assignment. If you can complete this assignment, your processing of sequence with the sequential network, with RNN, and with LSTM should be clear. I have not written here a CNN, but if you are feeling interested, you can do that as well. Because if you can reach up to 11, I'm sure that a couple more experiments you can perform just to see how CNN is performing on this task. Right. Let's see if our execution have completed. This is RNN, this is CNN. Both of them have completed. Here, the accuracy that we have achieved is around 89%. I think this is RNN, right? No, this is LSTM, 89%. This one is our CNN. CNN has also completed. The accuracy, the base it has achieved is around 83%. So you can see its accuracy is much less, but this took a lot longer than CNN. So usually when you do not have very strong machine, you do not have access to GPU, the data set is too big, and if you can compromise on some accuracy, then CNN is your answer to the problem. But if you've got a lot of data, if you've got access to high power machine, and if you say that accuracy I cannot compromise, then you will go for LSTM or maybe buy LSTM. Right. Okay, so I now open the forum for question. If you have any, I can welcome. Otherwise, we can stop the lecture here. Questions, guys?
सर वी नीड प्रैक्टिस टाइम, तो उसके बाद ही हम ये जो है ना सारी चीजें एक मरतबा हम देखेंगे। तभी आप ऐसा करें, एक सेशन क्रिएट कर दें, उस पे फॉरम क्रिएट करते हैं, तो हम वहाँ पे क्वेश्चन कर लेंगे और अगली क्लास में पहले वही डिस्कस कर लेंगे क्वेश्चंस।
यार असल में यकीन करें, मैंने इतना मुझे समझे कि मेरे आंखों में आंसू थे जब मैंने ये फोरम क्रिएट किया और किसी एक बंदे ने भी सवाल नहीं पूछा। मैंने कहा यार ये क्या बात हुई, मैंने ये शराफतन हुई। मैं थोड़ा ना ये कोर्स होम पे आ गया। आई एम क्रिएटिंग फोरम, आई क्रिएटेड दिस वन, नो वन यूज्ड है, किसी एक ने भी सवाल नहीं पूछा। अच्छा
सर ये हमें याद,
अब दया
सर ये हमें याद था, उसमें हमने जो किया था ना वो क्वेश्चन की थी एक।
चले ओके, अब मैं ना फोरम क्रिएट कर रहा हूँ फॉर CNN RNN है फॉर ओके 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 आई कम हियर। सो ये पहला पार्ट हमने ऑलरेडी अपलोड कर लिया है। मैं दूसरा पार्ट अभी जैसे ही ये मीटिंग खत्म होगी तो मैं अपलोड कर लूंगा। ये लेक्चर आपका पड़ा हुआ है, ये आपकी असाइनमेंट पड़ी हुई है। नाउ आई एम गोइंग टू एड द फोरम है, फोरम 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 ओके एड ask question, see RNN LSTM by LSTM GRU. Right, you can ask question. Okay, use this forum to ask question before Wednesday 12/19/18, right, 18 December. Right. So any question which is posted here before December 18, I will be answering. Right. Okay.
सर असाइनमेंट की लास्ट डेट भी नेक्स्ट क्लास से पहले तक है?
नहीं, नेक्स्ट क्लास तक।
यार मैं चाह रहा हूँ कि वेडनेसडे को आप जमा कर लें।
सर हम ट्राई करेंगे इंशाल्लाह। फिर भी अगर क्यूरी हो गई ना तो फिर हम उस दिन कर लेंगे। ये है हमारी कोशिश, यही होगी कि हम पहले ही क्लियर कर लें।
यस सर।
Ask question by clicking reply. ठीक है। Okay, so post forum. So you will click on this, right? And then you will click on reply to ask any question. I will answer that. Okay, so you want me to update deadline of the assignment, and there is a logic. You say that if still we will have any question, we will ask during class. We should have time after class as well. So okay, assignment time. I can update its submission time. Okay, 9:16 नहीं, आज है 12 ना, अगले होगी 19 है ना?
हाँ 10 तारीख है सर।
आज 10 है ना, तो फिर अगली तारीख होगी 18 है ना?
नहीं सर 19 ही होगी।
आज 10 है तो अगली थर्सडे 18 होगी ना, 17 होगी यार, कम ऑन। 17
सर 18 सही है, 18 सही।
17
यार मालिक का म्यूट कर दो कोई माइक।
17 will be next Thursday. 17 will be next Thursday. Okay.
6 बजे जागना है आप रात में।
Okay, save it. Okay, thank you guys. If you still have any question, otherwise I can stop and upload it on our LMS.
सर आपके लिए 17 से 18 करना बहुत आसान है सर, जैसे एक चेक करना है सर रोल।
क्या कह रहे हैं शकील?
मैं सर कह रहा था कि आपसे 17 से 18 करना सर बहुत आसान है सर, हमारे लिए बहुत मुश्किल हो जाएगा।
हाँ यार ये देखें 1 week is usually the time you give for assignment है. पहले थोड़ा अर्ली था इसलिए मैंने इसको आगे कर लिया है. ये दो फोरम क्यों बन गए? Why 2 forum? Anyway. Okay, guys, thank you very much. I'm going to stop this meeting and uploading its recording on LMS. Spend time on assignment, spend time on reading book, and spend time on your projects. Thank you very much. Allah Hafiz.
Allah Hafiz, sir. Thank you, sir. Allah Hafiz.